Hello everyone, welcome back to my YouTube channel. In the previous video, we have seen the introduction to Hadoop with its pros and cons. So now it's time to look at the core components of it. So here are the core components of Hadoop. So the first core component is the Hadoop Distributed File System, which is commonly known as HDFS. Then comes the MapReduce. Then we have yet another resource negotiator, which is also called as YARN. And fourth is the Hadoop common utilities. So in this particular video, we will be looking into Hadoop Distributed File System, which is the first and the important component of Hadoop. So this HDFS component is commonly used for storage of the big data. It is a high performance access point to the data that is distributed across different Hadoop clusters. These are nothing but the commodity hardwares where the data is stored in a distributed way. So let's say we want to store this particular file which is of the size 400 MB. Now as per Hadoop, data is stored in distributed format. So you can see that this data file of 400 MB will be distributed into 4 blocks. Each block will be having the size 128 MBs. Why 128 MBs? Because the maximum size of each block in HDFS is 128 MB. So you can see that 400 is exactly equal to 3 times 128 with a remainder of 16 MBs. So this 16 MB will be stored into a new block. Now what if one of the block crashes? So in this particular case, you don't have to worry at all because there is a provision for this, because at least 3 replicas will be made for each block. So you can see that these replicas will be stored in different Hadoop clusters. So in case if any of the block gets crashed or it doesn't work, then also it can be easily recovered. So you can see that HDFS is highly fault tolerant because it stores at least 3 copies of each data blocks and it is stored at different nodes. And also it provides high availability. That means if any of the block gets crashed, then also the data will be made available in a jiffy. Also note that HDFS is scalable and flexible. So I hope you have got an overview of what this HDFS actually means. Now it's time to look at its architecture. So HDFS follows a master-slave architecture. So first we will see the master part and then we will come to the slave part. So inside the master part, we have 2 components, that is the NameNode, which is also called as the heart of HDFS, and then we have secondary node. And note that these two goes hand in hand. Now if we come to the NameNode part, it stores 2 things. First it stores the file systems and then it stores the metadata. We will look into it in detail in the further slides. Next, when we come to secondary node, it maintains 2 things. It maintains edit logs and the FS image. Now if we come to the slave part, it stores the data nodes in which the actual data is stored, and this data nodes altogether serves the name node. So this is the entire architecture. Now let's have a look at all the components one by one. So first we will see the main part, which is the name node. So the name node stores 2 things. First is the metadata, which is nothing but data about the data. Now the information in the metadata is permanently stored onto a local disk, and this metadata can also include the edit log files, that means the information that is tracked at each timestamp, and the image of the entire file system. Now what this metadata actually includes, it includes the name of the file, the size of the file that it is going to work on, and then it will also store the address of the data node where this particular file is stored. Now this name node has all the information about the data nodes and also all the controls regarding it. Hence it is included in the master part of the architecture. Now also note that the name node instructs the data node to run these operations, for example create, delete or replicate. I hope you remember we have seen an example where the replicate operation is used. At least 3 replicas of each data block will be stored. Now there might be a case where the name node can get crashed. So in such scenarios, if the name node crashes, then the entire server which is associated with that name node will go down and the working will be stopped. So there should be a provision where it will deal with this particular problem, and there comes the use of the secondary name node, which is the next component of the master architecture. So the secondary name node maintains the edit logs and the namespace image information in sync with the name node server. That means whichever name node is associated with that secondary name node, it will store all the information of that particular name node inside it. So whenever the name node crashes, then the information that is stored inside the secondary name node will be used to revive that name node. Note that this secondary name node will include the file system image inside it, as well as the information logs with timestamp will be included inside it. So now I hope you know that how useful this secondary name node is. So to summarize, till now we have discussed the master part of the HDFS architecture, inside which the name node and the secondary node components are discussed. And note one thing, that this name node and secondary node will work in sync. That means all the information of the name node will be updated in real time way in the secondary node. So that was the master part of the HDFS architecture. Now let's have a look at the slave part. So inside the slave part, as you can see that data nodes are associated inside it. So what this data node actually means? It acts as the actual storage of the HDFS data. But note one thing, that all the information which is stored inside it will be stored in the form of blocks, as we have discussed in the previous example. Also note one more thing, that all these blocks will be constantly updating each information about all the operations that are performed on the data blocks to the name node. Also it will look for the block replications and will store inside it. So you can see that here in this particular example we have created 4 blocks. Now each block will have 3 replicas of it, and hence there will be total 4 times 3, which is 12 blocks, which will store the information of this 400 MB file. So that was the slave part. So now I hope that you have got the architecture of HDFS. To summarize, it includes 2 parts, master and slave. In master part, there is name node as well as the secondary name node, which coordinates and control the data node which comes inside the slave part of the architecture. So I hope the Hadoop Distributed File Systems concept is clear. In the upcoming video, we will be seeing another core component of Hadoop. If you like my videos, please like, share and subscribe to my channel. Also hit the bell icon. Follow me on Instagram.